Good morning, dear student. Welcome once again to the SRPPS online classes. As already we have discussed in our previous class, what are quadrilaterals? Let's have a quick recap. Quadrilateral means any figure which has four sides. Any closed figure which has four sides. So that kind of figure is known as quadrilaterals. Now, we have basically three types of quadrilaterals: parallelogram, trapezium and kite, right? So now today we will learn how we can convert a quadrilateral into a particular type of quadrilateral which is known as parallelogram. So let's start. Or how we can convert a quadrilateral or a four-sided figure into a parallelogram. So before that, let's read what is parallelogram or what are the requirements for being a parallelogram. Here you can see a four-sided closed figure with what are the basic requirements? Opposite sides equal and opposite sides parallel, right? How? This side is opposite to this side. So the measurement of these two sides are equal and these both sides are parallel to. These both sides are parallel to. Similarly, this side is opposite to this side, or I can show you in this way. This side is opposite to this side. So these are equal, or these have to be equal and they have to be parallel to each other. The arrow sign here shows these sides are parallel to each other. So when we make these changes in any four-sided closed figure, so that figure becomes or converted into a parallelogram. So we can say, in another word, these are the basic requirements to be a parallelogram. Opposite sides have to be equal and opposite sides have to be parallel, right? Okay. Now the next thing comes, what exactly parallel means, because equal, you know it very well, equal means equal in measurement. What does parallel means? Parallel means the distance, the vertical distance. What is the vertical distance between the opposite side has to be equal. If it is here from 5 centimeter, from this point also it has to be 5 centimeter. From this point also it has to be 5 centimeter, right? And another thing, and the distance between these two sides also has to be same at all the points. So we can say the lines are parallel, right? Another thing that you have learned in your previous classes, if we want to check out whether the given two line segments are parallel to each other, so what we are checking? Three conditions basically we are checking. Three conditions. Any of the three conditions we can check. Corresponding pair of angles, if you remember. Second, alternate pair of angles, right? And the third, the sum of co-interior angles. Co-interior angles have to be 180 degree. So if any one out of these three things will get satisfied, so we can say that given lines are parallel to each other. So now if I wanted to check the same thing in this kind of a closed figure, because we have done this thing in an open line segments, right? Two line or line segments we have checked in our previous classes, but here we have to check this condition in where? In a closed figure. We want to check whether this or this line is parallel to each other. So what we can do, let me show you what we can do now. Let's suppose we have a parallelogram. Now if I want to check whether this line or this line is parallel to each other, so what I will see, I wanted to see the parallel condition between these two lines. So the lines which are intersecting to it, it will be considered as a transversal, right? So if I'll just extended it to check this line or this line, I want to check whether they are parallel or not. So which of the property I can check, which is most easier over here. So I can see this is the transversal, as it is intersecting the both line at different point. So this angle and this angle at the same side of the transversal, and the both are interior angles, so they are co-interior angles. So if these two co-interior angles will make 180 degree, so I can say that these two lines are parallel to each other, right? Similarly, if I want to check whether the another pair of opposite side, that means this side or this side, are parallel or not. So now in the case of these two sides, this line is acting as a transversal, right? So what I can check, whether this angle or this angle, because this is a transversal, these are the two lines which I wanted to see whether these are parallel or not. So the angle at the same side of the transversal, and both are interior, so these are co-interior angles. So if these both angles will make 180 degree, so these two lines are also parallel to each other. So in other words, we can say that the third requirement for being a parallelogram, that adjacent angles are making 180 degree or are of 180 degree. Adjacent angles will always make 180 degree, right? So if I'll give the name to these angles, let's suppose it is angle 1, it is angle 2, it is angle 3, and it is angle 4. So here I can say that angle 1 plus angle 2 will be equal to 180 degree. Angle 2 plus angle 3 will also be equal to 180 degree. Angle 3 plus angle 4 will also be equal to 180 degree. And angle 1 plus angle 4 will also be equal to 180 degree, right? So this is the way I can say that the given figure is a parallelogram. So for our convenience, we can consider the first two condition as a primary condition for being a parallelogram, and this condition as a secondary condition, right, for being a figure as a parallelogram. Now the last thing about the parallelogram that I am going to discuss is its diagonal. What are the diagonals? First of all, we should know. So basically, diagonals are the line segment which is formed by joining the opposite vertices, right? So now we're going to join this. So here I'm going to tell you what are the properties of diagonals of a parallelogram. What we will see whenever we have any parallelogram with us and we are going to measure its diagonal. So what we will get, that this portion of a diagonal will be equal to this portion of a diagonal, right? And another thing that we will get, that this portion of a diagonal will be equal to this portion of a diagonal. So what it means? It means diagonal bisect each other. Already we have done and already we have measured in our classes that how we can prove that the diagonals are equal to each other. So whenever any parallelogram is given to us, so we can say that diagonals always bisect each other. It means this portion, if it is 10 centimeter, so the another part of the diagonal will also be 10 centimeter, and similarly if it is 20 centimeter, so the another part of the diagonal will also be 20 centimeter. So these are the basic properties of a diagonal. So let me sum up what properties we have discussed. So the first property that we have discussed is opposite sides are equal to each other. Second, opposite sides are parallel to each other, right? And third property that we have discussed, adjacent angles. You can call adjacent angle, or you can remember adjacent angle by the name of neighbor angles, right? So adjacent angles will always sum up 180 degree, and the last is diagonal bisect each other. So these are the properties of parallelogram. I hope children you get all these property. In the next class we will discuss how we can convert a parallelogram into a rectangle, square or rhombus. So stay happy. Bye bye.